Sir OMG doesn't mean much. Okay, so we have 10.3 number OMG calculus. Okay, so we want to simplify 1 over the square root of x plus h minus 1 over the square root of x all over h. Guys cool with this?
No.
No. Okay. This is just a thing, right? This is just a rational, like a scary fraction with roots in it, right? It's horrible. Yeah, this is like super scary fraction land. But you guys know what to do with scary fractions. What do? Yeah, I got something divided by something, right? This something's already a fraction, right? I might like, oh, it's h over 1, yeah? This top thing is, it's horrible, right? But it's just a fraction, so all I need to do is find a common bottom, and then I can flip this thing over and multiply, right? You guys with me on that? Okay, so let me just fiddle with the top. I want a common bottom for the top. What's the common bottom?
Square root of x times square root of x plus h.
Oh yeah. Hey, that's cool, right? So my CB is root x times root x plus h. That's totally terrifying, right? But I can get that. What's this guy need?
Square root of x.
It needs a root x top and bottom. That's a minus 7. What's this guy need?
Square root of x plus h.
Cool.
Don't those like cancel out though?
No, because they're different.
X and x plus, so root x and root x plus h are different, right?
Right, no, yeah, that's
That
Well,
you're good with?
That's only if it's like if that equals something where you can cancel it out on both sides.
Yeah.
Like you're not doing it to both sides because there's only one side. Does that make sense?
Right now I'm simplifying an expression.
gotcha. Oh man, just keep going.
Okay, let me
I
know.
don't think anybody just said made any sense.
I don't know. I don't know
Okay,
if I-
let's go one more step and see if that sorts it out. So let's see, I've got this is multiplied by this stuff, so I get a what out of the first piece?
Root x over x times x.
Okay, cool. And then there's a minus, and what's the other guy?
Root x plus h over root x times root x plus h.
For some reason I wrote those in the other order, right? But whatever. Okay, and then this is divided by h over 1. And so I say, okay, now what?
You combine the top.
You could multiply it by 1 over h, the top part.
Okay, so first I should combine with the common bottom, and then I should flip over and multiply it by 1 over h. Okay, so I got, let's see, what do I get on the top when I combine those two?
Root x minus root x minus root x plus h over your common bottom.
Okay. So I get root x minus root x plus h over the common bottom. And then I should be multiplying this by
1 over h.
1 over h. Let's go with that. Okay. Am I fully simplified?
No, it's going to multiply 1 over h.
Yeah, I'd have to put this in there, right?
Yeah.
Which you could literally just do right now.
Yeah, which I could really just do. So I could say this is root x minus root x plus h over h root x plus h. Cool. All right, now I was kind of hoping for something to cancel, right? And don't worry, if you were a calculus student right now, you would know that you have to cancel a frickin' h. This h has got to die. There's a calculus reason for this, but my goal is to get rid of that. So my goal is to get rid of that. I might say, I don't know, try to rationalize the top, maybe I'll be able to cancel an h then. So what would I multiply by to get rid of this funky difference of root things on the top?
Root x plus h?
Yeah, this is the same thing we were just doing, right? So I should multiply by the conjugate.
And the bottom as well.
And the bottom as well. Okay. So I get, let's see, on the bottom something terrible, right?
Yeah.
This was the price I had to pay to get rid of the roots in the top. I'm going to get more roots in the bottom. So right now my bottom consists of what?
H root x plus h times the quantity root x plus h.
That's nice.
Okay, cool. So I've got the common bottom I had before times the conjugate of the thing I just multiplied by. Right? Terrifying.
Yeah.
But it's just stuff, you know, just keep carrying it around. All right, then what do you get in the top? This is the payoff.
Root x squared plus root x times root x plus h minus root x times root x plus h.
Good, you spelled FOIL right this time.
Okay. Minus root x squared plus h squared.
Root x plus h squared.
Squared.
Right. Okay, so now what cancels? The cross terms, right? The O and the I.
Yeah.
And then you get x
What?
minus x plus h.
So I get x minus x plus h. And all this is over all this horrible
The
business.
fanciness.
Oops. That was root x plus h, right? All sorts of horribleness. Now what
Shouldn't it be
happens?
squared on the top?
Should they be?
Oh no, you got rid of the square roots. Sorry, I didn't notice that.
Okay, now why aren't I worried about absolute value bars or plus or minuses or?
In the original, that would have caused rooting by negative.
Yeah, in the original I'd have a problem. And actually I still have all those things floating in the bottom. So those are still restricting my domain. I don't have to worry about domain issues right here.
Could that be different though, if you were to say x was -4 and h was negative or +5?
Sure, but I can't plug -4 in for x
Oh,
because of
okay.
this guy. Really not sure introducing complex numbers is a good idea.
X is 0, right?
So
H
x minus x is 0.
1, so you have 1 over the x, or root x times root x plus h.
All the nonsense
Yeah,
without
all that over.
the regular h.
Yeah, all this nonsense without the regular h. Except you lost one thing. What did you lose? Anybody see what he lost?
The h.
He lost an h, but he did that on purpose.
Negative 1.
Why?
Distribute.
Yeah, you have to distribute this negative through, which gives us a negative h over h. Isn't 1, but is
Negative 1.
negative 1. Cool? This is as simplified as you can go.
And you don't bother multiplying that out?
No, because the next thing you're going to do on the calculus problem is you're going to plug h equals 0 into this. So really, this is part of a big calculus thing. That's find the derivative of a function using the limit definition, and you go through this business, and then at the end you plug h equals 0 in here, right? And so you learn something. We don't have a context for what you learn or why you would do this, right? But we can actually do the simplification part, which is, believe me, the hard part, right? This is clearly hard, right? You guys all with me on that?
Yeah, but I
Like-
like that better.
So
It's just easy to lose stuff.
No.
Yeah.
This is easily the hardest part of this very chill calculus problem, right? There's a very chill calculus beginning and a very chill calculus end, and the hard part of this problem is all the algebra.
Journey.
Yeah. And you want to know how many students get these right?
A few.
Yeah, like 2 or 3. Because they don't know how to multiply by a conjugate, or they don't know how to rationalize, or they don't know how to, well, keep track of fractions without screwing it up. So if you guys can do a good job of keeping track of fractions, you're going to have some major success in the rest of the math classes. They are all really pretty easy if you're good at algebra. Cool? Okay. Teaser for what this is good for, I guess.